Greetings Specialist, Commander King here, and in this video I'm taking a look at electron configuration and orbitals and how electrons like to fill in those orbitals. But the reason why we might need to do that is we need to figure out how atoms behave first of all, and it can give us some suggestions as to whether things are paramagnetic and affected by magnets. Okay, so we want to take a look at that. So let's kind of think about nitrogen. Right? Remember, electron configuration and orbital diagrams are talking about electrons. Nitrogen is right here on my periodic table. And I'm thinking, all right, well, let me move this over here for a better visual. Okay, I'm thinking, how do I fill in this orbital diagram for nitrogen? Well, I need to figure out how many electrons go into nitrogen. Nitrogen's there, 1, 2, 3, 4, 5, 6, 7. So I know I got 7 electrons I got to put in. All right, and I'm thinking, all right, well, I got 7. I know electrons like to start at the lowest energy level. So they like to start at the 1s because electrons are kind of lazy. They don't like getting up and using energy to do stuff, kind of like humans. And so, all right, I'm going to put 1 electron there. Now, the thing I remember, each orbital can hold 2 electrons, so I could put 2 in here. I remember electrons like to spin the opposite way if they're in the same orbital, so I'm going to draw those half arrows spinning opposite ways. I put 2 electrons, I still got 5 more. Now this one is filled, so these electrons now, the remaining electrons, got to go in the next energy level, the next lowest, which is the 2s. So I'm going to put 1, 2. I've got 2 electrons there. All right, so I've put 4 electrons in out of my 7. I've got 3 electrons left. And here's where it gets tricky, okay? You got to remember that electrons, if they can, they don't like to share, okay? They don't like to be in the same orbital if they don't have to, all right? So all things being the same in the 2p, right? I could put 1, 2, 3, but then these 2 electrons would be sharing and they would be kind of repelling against each other. They don't like that. Instead, what they want to do is they like to spread out, and so they like to each take their own orbital, and so each electron occupies its own orbital in the 2p, or their own 2p orbital, and that minimizes the energy here. So now we've got 3 electrons on here, each in their orbital, and so that's that. Now if I were to write the electron configuration, I could say, all right, well in the 1s there are 2 electrons, in the 2s orbital there are 2 electrons, and in the 2p orbital there are 3 electrons, and this gives me the location of the electrons. Now, if I were looking at the nitrogen atom alone, without any other factors involved, not looking at nitrogen molecule, I'm just looking at the nitrogen atom, and I'm thinking about, well, could this be affected by magnets? Well, the key is, are there any unpaired electrons? See, when electrons spin like this, okay, in one direction, they're generating a magnetic field. And when you generate that magnetic field, you're affected by magnets. You're paramagnetic. So in this case, you do have 3 unpaired electrons. Those are both spinning. We can think of them spinning up, all right? And so what's actually going to happen is that this is paramagnetic, all right? Oh, my handwriting's still awful, paramagnetic. And yeah, all right. So cool. We figured out that one. Now let's move to chromium. Chromium, 1, 2, 3, 4, is in the D block. So remember SPD block right here. And all right, let's try to figure out what's going on there. So let's take a look here. Chromium, I've got how many electrons in chromium? Geez, 2, 4, 10, 12, 16, 18, 22 electrons, is that right? 22 electrons. This is 20. I think 24 electrons. Did I count on 2, 4, 10, 12, 18, 20, 24. Yeah, 24 electrons. All right, great. So we got 24 electrons to go in. I'm just going to start off 1s, put 2 electrons, 2s, 2 electrons, the 2p. I'm going to fill them like this because remember the electrons like to fill in like that. They like to spread out and then double up. So far now I've used 10 electrons. 2 more makes 12, 13, 14, 15, 16, 17, 18, 19, 20. Get to the D block. Again, I got to remember I got 4 more electrons. They would rather not bunch up. So if I were to draw something like this, remember the electrons are very negative, repel each other. like to split across those orbitals if possible. And so what I'll actually see is those 4 electrons will spread out like this. So if I'm going to write the electron configuration, well, in the 1s, I've got 2 electrons. In the 2s, I've got 2 electrons. In the 2p, I've got 6 electrons. In the 3s, I have 2 electrons. In the 3p, I've got 6 electrons. And in the 4s, I've got 2 electrons. And in the 3d, I've got 4 electrons. So there we go. That's CR. And again, I see these unpaired electrons, so I would think that chromium could be paramagnetic. Now, once you get beyond 1 atom of chromium, different things can happen. So it's not necessarily true that the chromium metal will be magnetic, but at least that atom theoretically should be magnetic. All right, let's talk about rubidium. Rubidium, way down here. Rubidium, 1, 2, 3, 4, 5. Rubidium. Okay, rubidium has how many electrons? Well, let's see. Calcium has 20. Then we got 10, 30, 36, 37 electrons, I think rubidium has. Okay, I just look at my periodic table. You know, the atomic number tells me for a neutral atom. 37 electrons, so let's plug those in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Notice how I spread them out first so I don't forget that the electrons don't like to pair up. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I need one more, 1 electron there. And so you get the idea, 1s2 all the way up to 5s1. Again, that Sloan electron here spinning up, nothing to cancel out that spin, and so this suggests that this might be paramagnetic as well. At least the rubidium atom would be, but not necessarily in a greater scale. Okay, so I hope this was helpful. King out.